Hi, my name is Luciana. I am a biologist from Brazil, and I am currently a second year master student in pharmacology at the University of São Paulo. I work on marine pharmacology lab, and the theme of my dissertation is on the cancer potential of isolated compounds of Streptomyces sp recovered of Acidia Eugemmania sp. First of all, I would like to thank the Beyond Science Initiative team for the opportunity to present my research in this conference and to congratulate for this initiative. The work I am presenting today is entitled Evaluation of Marine Bacterial Extract and Fraction Contain Proteasome Inhibitors in Glioblastoma cell lines. It's important to talk about marine environment because about 70% of the Earth's surface is water covered, making the marine environment an immense source of new bioactive compounds with uncommon and unique chemical features. Since the 90s, several marine natural products and their application towards marine biotechnological and therapeutic potential were reported. Marine organisms include about 2.2 million of the organisms for several phyla. The forced coexistence among these organisms induced the development of exceptional defensive mechanisms to repel or destroy predators through the production of potent compounds, often referred to as secondary metabolites. A large number of bioactive compounds were isolated from sponges, cnidarians, ascidians, microorganisms. Some of them are approved by FDA and currently used in clinical trials. This first graph shows an increase in the marine natural products production by microorganisms in relation to the other organisms. These compounds present anti-cancer, antibacterial, antifungal, antiviral, and other pharmacological activities. According to the NCI, there will be close to 24,000 new cases of glioblastoma in 2018, according to the death of close to 70,000 people worldwide. The low rate of survival among the patients led the World Health Organization to consider glioblastoma multiforme an orphan disease. The current therapy for glioblastoma is based on surgery, radiotherapy, and chemotherapy. Mainly use the alkylate compounds as lomustine, temozolomide, and procalcitonin. More recently, the VEGF antibody bevacizumab is also used, but with limited access. Thus, it's very important to find new effective therapy, and proteasome inhibitors can to emerge as promising candidates to treat this disease. There are 3 approved proteasome inhibitors mainly used to treat multiple myeloma: bortezomib, carfilzomib, and cyclizumab. I want to highlight here marizomib that was isolated from marine bacteria and is currently on phase 3 clinical trials for glioblastoma treatment. It's important to talk that proteasomes are part of a major mechanism by which cells regulate the concentration of particular proteins and degrade misfold proteins. Proteins are targeted for degradation with small proteins called ubiquitin. The result is a polyubiquitin 10 that is bound by the proteasome, allowing it to degrade the target proteins. Well, the aim of the research is to evaluate new compounds proteasome inhibitors isolated from marine bacteria. Now, I'm going to talk about experimental designs. The bacterium presented in this work was isolated from Eugemmania acidia that was collected in northwest coast of Brazil. The bacterium was recovered using salutated media, and after its isolation, it was grown in liquid medium for production of the extract and, consequently, secondary metabolites. After that, the extract was separated in some fractions. For test the biological activity of the extract, we did 3 assays: MTT, SRB, and proteasome inhibition. The first and the second, we evaluated the growth inhibition in tumor cell lines, colon carcinoma, and gliomas. And the third, we evaluated the inhibition of the specific proteasome catalytic subunit, chymotrypsin-alike. We investigate the electronic link between the compound and the subunit through crystallography. Here we have the results obtained at the moment. The analysis showed that one of fraction obtained from extract inhibited the growth of tumor cells strongly. This value compared the potential of the fraction and the doxorubicin. The extract was tested in proteasome, and we can see that it inhibited the chymotrypsin-alike activity. Its inhibitory concentration mean was 0.42 micrograms per milliliter. By means of crystallography images, it was possible to predict the structure of the molecule present in the extract that bounded with proteasome catalytic subunit. Here, we have inhibitors electron density bounded to the threonine result with mix up the catalytic subunit. We continued these studies to discover the molecule, and through network analysis and GNPS database, we identified ion correlated with the compound TMC86A present in the literature. From these results, we solved to compare the potency of the fraction with some non-proteasome inhibitors, and through the SERB assay, the value of the growth inhibition mean of the fraction is close to the Salmon's pyramid A value on a red-related compound. At the moment, we are investigating the protein expression in glioma cell lines treated with the fraction to compare with other inhibitors. We decided to mark ubiquitinate proteins and proteins related with reticulum stress as HSP70. And in these Western blots, it's possible to see that cells treated with the fraction expressed more ubiquitinate proteins and more HSP70 protein. We test the IC50 concentration in 3 different hours, 24, 36, and 48 to observe this relation with time. And conclusion and perspectives. To conclude, marine bacteria isolated from Euherdemonia aspi acida produces proteasome inhibitors compounds like TMC86A. The results presented in this research emphasize the anti-cancer potential of this compound. And for perspective, I intend to investigate the mechanism of action caused by TMC86A in glioblastoma cell lines. I would like to make some acknowledgments to Professor Leticia Costa-Lotufo, my advisor, Professor Paulo de Mendes, Professor João Machado Neto, Professor Daniela Trivella, and Rafael de Felício, collaborators, to my work group La Pharma, to Institute of Biomedical Sciences, University of São Paulo, and mainly to support financial, CNPq and FAPESP. Thanks for your attention.